In this video, you will learn how to use the predictive modeling capability of Watson machine learning with streaming data. In a Watson Studio project, you'll create and edit a modeler flow. Using that modeler flow, you'll train an SPSS predictive model using Watson machine learning, which tells you what is the best drug to prescribe given different health metrics. You'll then create a streams flow which will ingest streaming patient metrics. The predictive model used by the SPSS model operator will determine which drug would be most effective for each patient. Start in a Watson Studio project that already has the machine learning and streaming analytics services associated. If you don't have those services associated yet, you can set that up on the Project Settings tab. Now add to the project a new modeler flow. In this case, you'll use the drug study example modeler flow. This modeler flow reads training data from a CSV file, computes the sodium to potassium ratio, removes the sodium and potassium columns from the data, and defines the target column. After that, it applies the C5 algorithm to calculate predictor importance. Two new columns are auto-generated, C drug and CC drug, which are the predicted drug name and the confidence score. Running the flow creates a new node that holds the new model from the modeler flow. This model has the two new columns. Let's rename them to be more meaningful. Drag and drop a filter node to the canvas. Then drag a table node. You'll use the filter node to rename the two new columns to drug name and confidence. When you run the flow, check the output in the table node and note that the two new columns are renamed to drug name and confidence. Everything looks good, so save the modeler flow as a new model called drug model. The new model will use the machine learning service associated with this project. Now return to the Assets tab in the project to see the drug model and the drug study example modeler flow. Open the new model to check its input schema. You'll need to know what columns the model expects in order to set up the streams flow to deliver those columns to the model. First, create a streams flow in the same project as the new model. The streams flow will ingest patient data in the columns that the model expects. First, drag and drop the code operator onto the canvas. Next, add the SPSS Model operator to the canvas. And lastly, drag the debug operator to the canvas. Now connect the operators in order. The code operator lets you put in Python code that reads the ingested patient data. Next, edit the output schema to add the column names that you saw in the input schema of the machine learning model: age, sex, blood pressure, cholesterol, sodium, and potassium. The SPSS model operator will run the machine learning model you created from the modeler flow. You'll see that the columns are mapped from the code operator to what the model expects as input. Notice that the model expects a column for drug, but that column doesn't exist in the code operator. So you'll have to go back to the code operator, edit the output schema, and add the drug column. Now in the SPSS model operator, you can map the drug input parameter to the drug column. Next, edit the output schema to verify that it includes the drug name and confidence columns from the model. These two variables will be used to analyze data in the other columns to predict drug effectiveness. The debug operator lets you run the streams flow in the metrics page without storing any of the data. Here's what the completed streams flow looks like. Now save and run the new streams flow. Once it's running, you can see the current throughput as well as look at the actual flow of events between operators. Look at the flow of events between the code and the SPSS model operators. You can see the actual data in table format. When you look at the flow of events between the SPSS model operator and debug operator, you see the predicted drug name and confidence score for the best drug to use with the given health metrics. Find more videos in the Cloud Pak for Data as a Service documentation.